Hello and welcome. So we'll be looking at Carnot efficiency in the PV diagram. First, if you have been following us from this lecture, you are going to know fully well that diagram above PV diagram of Carnot cycle. Alright, so we have proved the Carnot efficiency S diagram. So let's use the PV diagram to also prove the Carnot efficiency. First, examination, you can ask either use PS or PV diagram. All right, so it's good to learn both. All right, so for us to start this, first thing we are going to do is we know that we have four states here. We have state one, we have state two, we have state three, we have state four. So for our state one, sorry, for our state two, we said PV diagram, right? So for our state two, this state two, it means what we have here is P2, P2. State three, what we have in state three is P3, P3. What we have in state four is P4, P4. Similarly, this one is going to be P1. All right. So the next thing we are going to do is we are going to be moving from this point to this point, this point to this point. So let's number this place to be A, B, C, and D. Okay? All right. So from here, we know that from A to B is an isothermal process, right? And from an ID gas, we said for an ID gas, we know that PV, P1, B1 all over T1 is equal to P2, B2 all over what? T2. So for an isothermal process, what is going to happen? T1 will be equal to T2. Then this will cancel out. Then P1, B1 will be equal to P2, B. So that is what. So now let's apply this to state 2 and state 3. All right. So it means here we are having P2, P2, B2 to be equals to, that is all over T2 to be equals to P3, B3 all over T3. All right. So for an isothermal process, T2 will be equals to what? T3, right? So T2 is equal to T3, that is isothermal process. All right. So it shows that if we do that, T2 will go with T3, then we'll be left with what? We're left with P2, P2 to be equals to P3, P3. So let's name this equation 1. All right. Now, when we move from B to C, what do we have? In our B to C, we are having adiabatic process. And don't forget, we said for an adiabatic process, PV gamma is equal to what? Constant, right? It means that P3, B3 gamma will be equals to P4, B4 gamma. So we are going to have P3, B3 gamma to be equals to P4, B4 gamma. So let's call this equation number 2. So you should know that the reason for this is for adiabatic process. All right. So for C to D, what do we have? We also have an isothermal process. So it means P4, B4 will be equals to P1, B1. P4, B4 will be equals to P1, P1. So equation 3. So the last one that we have here is D to what? To A. Of course, it is P1 because it is adiabatic. And we know adiabatic obeys PV gamma equals to constant. So what we have here is going to be P1, B1 gamma. We are going to have P1, B1 gamma equals to P2, B2 gamma. Equation number what? 4. So now the next thing we are going to be doing is We are going to multiply everything we have at this side to be, and we are going to equate it to everything that we have at this side. We are going to multiply everything that we have at this side. So we multiply the left hand side, everything we have at the left hand side. So this multiplied by this, multiplied by this, multiplied by this is going to give us what? We're going to have P2, P2, P3, P3, gamma. Then we are going to have P4, P4. Then we are going to have P1, P1, gamma, which is going to be equal to what? P3, P3. We are going to have P4, P4, gamma. Then we are going to have P1, P1. Then we are going to have P2, P2, gamma. All right, what do you observe? You observe that we have P2 here, we have P2 here. So P2 will go with P2. All right, we have V2 here. We have V2 here. Okay, we only have V2 gamma, so we leave that. We have P3, we have P3. So P3 will go with P3. All right, so we have P4. We have P4 here. All right, we have P4. So P4 will go with P4. So we'll be left with, okay, we have P1, we also have P1. So P1 will go with P1. So we'll be left with what? We'll be left with P3 gamma and V4 and V1 gamma to be equals to V1 gamma, V4 and V3 gamma. And we also have V2 here. All right, we also have V2. So let me put V2 here. All right, to be equals to, so we have V3, we have V1, then we have V2 gamma. So we have V4. All right, let me look at this properly. V3, V4 gamma. Then we have V1 and we have V2 gamma. All right, so you can see it is balanced. Now the next thing is we are going to be dividing both sides by V1, V2, V3, V4. All right, let's divide both sides by V1, V2, V3, and V4. So V1, V2, V3, and V4. All right, so V2 will go with V2, V4 will go with V4. Then we'll be having V3 gamma all over what? All over. So we'll be left with V3 gamma, then V1 gamma all over what? All over V1 multiplied by what? V3, which is equals to, here we are going to have V3 will go with V3, V1 will go with V1. Then we'll be having V4 all to the power of gamma, V2 all to the power of gamma, all over what? All over V2 and V4. All right. So now from the law of indices, this is V3 to power gamma, all over what? V3, right? So from the law of indices, we know a to the power of x divided by a to the power of y is nothing but what? A to the power of what? X minus y. So here, if I pick V3, I can multiply. This one is raised to the power of 1. So it's going to be V3 to the power of gamma minus 1. So we are going to have V3 to the power of gamma minus 1. Similarly with this, I'm going to have V1 to the power of gamma minus 1, which is equals to V4 to the power of gamma minus 1. Then we are going to have V2 to the power of gamma minus 1. All right, what do you observe? You observe gamma minus 1 is common here. Gamma minus 1 is common. We can factor them out. So we are going to have V3, V1 all to the power of gamma minus 1, which is going to be equal to V4, V2 to the power of gamma minus 1. So gamma minus 1 will go with gamma minus 1. Then we are going to have V3, V1. We're going to have V3, V1 equals to what? To be equals to V4, V4, V2. All right. So now I can decide to write this expression in 4 ways. Number 1, I can by, I can decide to say V3 over V4, V3 all over V4 will be equals to V2 all over V1. One. All right. I can decide to write V1 all over V4, V1 all over V4, then equals to V2 all over what? All over V3. Two. All right. The other way that we can do is this. We can decide to write this as V4. We can decide to write this as V1 all over V4. Okay, I've written that. We can decide to write it as V1 all over V2. We can decide to write V1 all over V2. V1 all over V2, then will be equals to V4 all over V3. V4 all over V3. The last one, you can decide to write this in form of V4, V4 all over V1, and decide to write this in form of V4 all over V1 to be equals to V4 all over V1 to be equals to V3 all over V3 all over V3 plus multiply V1. All right, correct. All right, so these are the four ways of which we can express. So the next thing we are going to be doing, we have established this part. So the next thing we are going to be doing is we are going to be going for the efficiency now. We are going to be calculating the efficiency. All right, we know that the Carnot efficiency is equals to what? Is equals to the work done all over what? Heat supply. So here we are going to be using the work net all over the what? The heat supply. This we want to calculate the work net. This is the total work done throughout when we move from A to B, from B to C, from C to D, and from D to what? To A. So let's look for the work net. We know that our efficiency Carnot equals to work net let me just denote it. Work net all over what? All over heat supply. This and the heat supply is what? QA, that is the heat added. All right. So when we talk about work net, I'm talking about the total work done throughout the cycle. So it means that is the work done from A to B, work done from A to B, plus the work done from B to C, work done from B to C, plus the work done from C to D, C to D, plus the work done from D to A, D. Right. So this is our work. All right. Now the next thing we are going to be doing is we'll be calculating for each of these work individually. Then after what we get there, we'll come and substitute. Then we move on with the next thing. All right. So now we are going to start with the work done for what? Our AB. Now, before we do that, you are going to recall from the first law of thermodynamics that the Q equals to what? Equals to the U plus what? Plus is it W? Yeah, W. Let's use W. All right. So for this, then we can rewrite this as Q plus U plus change in work. So, this is W rather. All right. Now let's move on. So, but for and we know that this process A to B is nothing but what? An isothermal, right? An isothermal process. And for an isothermal process, what do we have? We say that there is no temperature, right? That is change in temperature is equal to 0 and the internal energy is therefore equal to what? 0. The change in internal energy is equals to 0 as well. So it means our dq will be equals to what? Will be equals to W. I hope you understand. All right. Now, and we note that the uh, the W that we have here, W is equals to the Q. Now, because we are referring to this process only, that is A and B, so we can say that our dq here is same thing as our what? The heat supply. So we can say that QA is equals to W. All right. And the work done we are referring to is what? From A to B. So A. All right. And you are going to recall for an isothermal process that W, an isothermal process. Let me write this before I come back to this. Let's leave it. Let's leave it. A to B, right? Yeah. And you are going to recall for an isothermal process that the work done for an isothermal process is nothing but nRT and link of V1 all over V2, V1 all over V2. So we are just going to apply this because you know here we are dealing with process 2 and 3. So this formula does not, you cannot hold. But we are just going to write similar thing, but we are going to be relating it to the work done from A to B. All right. So we can therefore say our work done from A to B will be equals to nRT, but the temperature that we are referring to here is going to be between T2 and what? T3. All right, so this is going to be in ln of that is V3 all over what? V2. V3 all over V. All right. Of course, so the temperature we have here is going to be T2. And you know from our TS diagram, T2 will be equal to what? T3. So let's just take this as what? T2. All right. So now we can therefore, since we know that work done between A and B is equal to this, is also equal to what? The quantity of heat added. So we can say QA equals to WAB, which is equals to nRT2 ln of what? Ln of V3 all over what? V2. So that is about that. So now let's go for the work done between B to C. You know, B to C is a what? It's an adiabatic process, and you can recall from an adiabatic process under thermodynamics, we have proven that P1 V1 minus P2 V2, this W is equals to P1 V1 minus P2 V2 all over what? Gamma minus 1. So that is what we are going to be using here. So now WBC equals to, so we are referring to stage 3 and stage 4. So it's going to be what? P3, V3, P3, V3 minus P4, V4, P4, V4 all over what? Gamma minus 1. All right, so the next one is work done from C to what? From C to D. So from C to D, C to D is also what? Isothermal. So we are still going to be applying this to it. But the only changes here is, don't forget, this one is heat addition. So this one is what? Heat rejection. So it's rejecting. And you know, when it is rejecting, the sign, there will be equal, but the sign will change, right? So now we are going to have N RT. So the T we are going to be using here is what? Because we are having T1 and T2. Because T1 will be equal to T1 will be equal to T4 in your what? In your TS diagram. So we're using T1 here. Then ln of ln of V ln of V1 over what? V4. Ln of V1 all over what? V4. The reason for this is it's negative. It's supposed to be V4 over V1. Is that clear? but because it is negative, and you know the negative from the law of indices, if I take the negative, I can bring what is at the denominator up, then what is at the numerator down, so the negative will go away. So that is why we are taking the inverse here. All right. So now the next one is WDE. W is work done from D to A. And see, D to A is an adiabatic. And we already said this is an adiabatic process. So we'll be applying it. So we suppose, from this side, we move from this to this, that is this minus this over gamma, right? Don't forget, here too is compression. So you cannot, it's going to be the negative of what we do at this side. Please take note of this. So this is compression. So we cannot say P1 V1 minus this. We cannot say, here we say this minus this, right? So here we cannot say this minus this. No, it's going to be this minus this. So we are going to have P1 minus P2 all over what? All over gamma. All right, so we are going to substitute everything that we have for our work for A to B, B to C, C to D, D to A, this work net. So if we do that, let me just clean this side. All right, so if we do that, our work net will be equals to, for A to B, what do we have? For A to B, we have nRT2, then ln of what? Ln of V3 all over what? All over V2 plus W, that is VC, then we have P3 minus P4 all over gamma minus 1, then plus have nRT1 and ln of what? Ln of V1 all over what? Then plus what? Plus which is P1 minus P2 all over gamma. All right, let's clean this part off completely now. All right, so the next thing we are going to be doing is, now if you go back to our previous class, sorry, from the beginning of this lecture, just that I've wiped some things off, we already established that our P1 V1, where do we have P1 V1? This is P1 V1 will be equals to this, will be equals to this, and this is equals to this for an isothermal process. All right, so now let's put this back here so that we can understand what I want to do. So for an isothermal process, we know that P3 equals to P2, and we also know that P4, V4 will be equals to what? Equals to P1 V1. So I've written this. That's what I used to derive this. That's what I used to establish this part. All right, from the beginning. Now here we are having P1 V1, right? P1 V1 will be equals to what? Going to be equals to P4 V4, right? Here we are having P2 V2. P2 V2 will be equals to P3 V3. So let's substitute them inside this equation. Then we can further write this work net. Work net will be equals to nRT2 ln of what? Ln of V3 all over what? V2 plus nRT1 into ln of what? Into ln of V1 all over what? V4, then plus having plus P3 plus P3 V3 minus P4 V4. Don't forget they are having the same LCM, right? So plus P1 V1 minus P2 V2 all over what? All over gamma minus 1. But don't forget, our P1 is already P4 V4. So I can replace P1 V1 here with P4 V4. And P2 V2 is V3. I will replace this one with 3 and 3. Now, what do you observe? You observe that P3 we cancel out, P3 V3 we cancel out P3 V3, P4 V4 we cancel out P4 V4. So everything here over 0, sorry, everything here will be 0. 0 divided by that one minus 1 is 0. And 0 plus everything we have here will give us. So our work net be equals to nRT2, then ln of what? Then ln of V3 all over what? V2 plus nRT1, then ln of what? Then ln of V1 all over what? V4. All right. Now, we look at this now. They're almost done. So here we have V1 over V4. So if you go to your part that we established here, V1 over V4 is equal to what? V2 over V3, right? So let's substitute that here. So if we do that, we are going to have work net be equals to nRT2, then ln of V3 all over what? V2 plus nRT1, then ln of V1 over V4 is equals to what? V2 all over what? All over V3. Right? All right. Now, how can we balance what is here and here? I can introduce my negative sign. Then this will come up, then this will go down. So now, work net now is equals to nRT2, then ln of V3 all over V2 minus nRT1, and ln of what? Ln of V3 all over what? V2. All right. So now the next thing that you will see is, you see NR is common and in ln of V3 over V2 is also common. So I'll factor that out. So by so doing, I'm going to have my work net to be work net, which will be equals to, if I factor out NR ln of V3 over V2, V3 over V3 all over V2. And I'll be left with what? I'll be left with T2 minus T1. T2 minus T1. All right, so this is my work net, right? Now, the next thing is our heat supply. Our heat supply, that is QA, we already said our heat supply will be equals to, the work done between A and B. And we already saw for the work done between A and B, you can see it here. The work done between A and B is nRT2 ln of V2 over what? Sorry, V3 over V2. So this will give us nRT2 ln of what? Ln of V3 all over what? V2. All right, now let's go back to our Carnot efficiency now. Now that we have our work net and we have our heat addition now, so we can get our Carnot efficiency. So Carnot efficiency will be equals to work net is nR ln of V3 all over what? V2. Then we'll be having this into T2 minus T1 all over what? All over Q heat added, which is nRT2 into what? Into ln of V3, or ln of V3 all over what? All right, so this is what we have. Now, what do you observe here? You observe that NR will go with NR, lane of V3 will go with lane of V3. Now be having our Carnot efficiency to be equals to what? To be equals to T2 minus T1 all over what? All over T2, which we can to divide both sides by T and have it to be equals to 1 minus what? T1 all over, sorry, all over what? T. All right. So, and you can see that this is same thing as what we have in our TS diagram. This is the same thing as what we have in our TS diagram. So I hope you have learned another thing in this video. All of this, we are doing it for the purpose of examination. Because we don't want you to see anything scary. Here we are going to give it to you, okay, you are going to meet it. Is that clear? So please do share this content with your colleagues who might be in need of it. Thanks.